Cool. So this is a presentation on dip molding by Courtney Wenzel, Michael Mosley, and Anna Witter. And dip molding, oh, I cannot, okay. Dip molding is often used to make sort of coverings for other parts rather than standalones, and it's because the process is really about adding a layer on top of either a metal mandrel or another part, sort of like a substrate, kind of like overmolding. And so it's a pretty repeatable process because you can just do a lot of dips at once. And there's a cool little video here that shows how that's done. And we're going to go more into depth about how exactly each piece is decided and how to do the whole process. But just overall, you heat up a part, you dip it in liquid plastic, you take it out, and you're done. So it's pretty easy in that way. And the video kind of shows that process. So they dip it in the plastic, and sort of the time that they leave it in, that all affects how thick the plastic coating ends up being. And sort of more in depth on that, you can see that you make a mold of the inside of your part. So rather than the typical molding process of molding the outside, now you want to think about, okay, what is the inside geometry of the part? And it can be a little bit more forgiving than molding the outside, because often these materials are pretty stretchy, and they're coating sort of, they can have overhangs because the material is already warm when you're taking it off, and so it can sort of snap over the overhangs, and it's not as unforgiving as a draft angle or anything like that in a typical molding process. So once you have the mandrel, then you just preheat the mandrel to a temperature that is a little bit difficult to get right and takes some thought, and I think a lot of trial and error, because you want to get the mandrel to the right temperature that will make the liquid material solid, but it won't burn it and it won't make it go too quickly. And so once you've sort of figured that out, you just dip the mandrel either multiple times or just once for a long time, or really quickly if you want a very thin coating. But basically, the hotter it is and the longer you leave it in, the more plastic is going to accumulate on that mandrel. But it's a pretty difficult process to sort of fine tune. But once you have it down, you can make a lot really quickly. The really interesting part of this is that once you take the mandrel out of the liquid, you actually heat it again, so that the plastic fuses to itself and not the mandrel, which is why it's really important to get sort of that chemical reaction between the metal of the mandrel and the plastic that you have in it. Like that's, you don't want to just sort of adhere it to your mandrel. It's not very useful. But so you heat it once, you dip it, and then you heat it again, and then you can just remove the mandrel either using just your hands or kind of shaking them, or you can use sort of pneumatic pins. So it's a pretty, like, 5 steps. It's not that many, and a lot of it is sort of a one-time step of making the mandrel and doing all of the fine tuning. So that's why it's a really cool process, and it is used to make a lot of different parts that you wouldn't expect.
So the parts that we get from dip molding and dip coating are really cool because they don't have parting lines or marks from gates or anything like that. The only imperfection you might see is the nubs on the bottom of part, the last part that is in contact with the plastic. So if you see nitrile or a pair of latex gloves or something, they're always a little thicker in the fingers because that's the last part coming out of the batch of plastic. And it's also really cool because you can have a wide variability in the durometer, texture, and thickness and color of your different materials.
Yeah, and so some common materials that would be used for dip molding. PVC, also known as plastisol, is probably the most common because it can be in many different textures and also has some interesting characteristics. However, as you can see, there are plenty of different examples: latex, neoprene, polyurethane, silicones, and epoxy that can all make these different products below. And plastis is probably, it was one of the original dip molding plastics to be used because at room temperature, it's actually liquid. And then you dip the hot mandrel into it in order to like get this coat to stick. Then afterwards, as Anna was saying, you cure the plastic and it permanently hardens. And so it isn't now liquid at room temperature. It fuses to itself, and that allows you to have either standalone parts like the kind of caps. I think that those are just like kind of cushion bottoms for some sort of heavy object that you don't want to scrape against the floor. But then you can also dip objects in and just give it an overcoat of plastisol, as in the chain in the top right.
Yeah, and that kind of leads into the advantages and disadvantages of dip molding and using this process. And so it can be really easy to get, like the mandrels themselves don't have to be really complicated. So it can be low cost to produce the mandrels or the mold, depending on who you ask what to call it. And once you have it set up, it's pretty low cost to keep it going. So you just have a big tub of plastisol and you just keep going. And it's pretty scalable because you can have like one test mandrel and run it, and it's not actually that much more or less expensive than running a whole bunch of them. So you can run one and then iterate on that pretty quickly. Because the curing times are all back to back, there's pretty short delivery times. There's a lot of different sort of colors and finishes that you can do. It is a lot of different like properties that you can do, but one of the limiting things about dip molding is that it doesn't make thick parts. You know, it's really not meant to make like a standalone block. You technically could dip over and over and over and over again and get like a pretty thick part, but once you start doing that, you're really sort of playing with your own time and your own, like, it's something is just a lot easier to go wrong and it's not very repeatable. As you sort of push the boundaries of the machines that are used for this, and so that is one of that gets into the two disadvantages, which is that it is like a slow process compared to injection molding. So injection molding, you can just churn out parts really quickly, but you can't iterate as fast. So it's slow to make like a single batch. Slow is a relative sense, it's not like days or anything. But once you have it, you can, like, once you have the machine set up, you can iterate much more quickly than remachining a mold and refinishing a mold and that kind of thing. But the other problem is that it is very difficult to control the thickness. And so once you have it set, it's okay, but getting it set is not easy. And like I said before, you can't really make sort of thick parts. It's really meant to coat things or to make little caps for things and not make a leg pull or something like that.
So in addition to all of the advantages of the molding process we just saw, there's also some advantages specifically compared to injection molding. So one of those is that you can get really complex geometries and have things like undercuts and overhangs that you wouldn't be able to mold with a traditional mold, or maybe you would need to use some really complex shutoffs and cam action kind of thing, but you don't really need to use that with dip molding. You can also layer different materials. So one example would be if you just wanted different colors of the same material kind of layered on a part, you could do that, or you could layer completely different materials too. So one really hard material and maybe a slightly softer material, or one that's textured. If you just want a textured layer on the outside, you're able to do that just by dipping the same product multiple times. It's also really great because you don't have internal stresses in the part, just because it's a thin layer. It's not like a solid block of plastic held in a really hot mold like you would get in an injection molding. And probably the coolest thing is that you can do it at home. You can buy this product called Plastidip, and it's more made for dip coating. So you can coat the handles of your tools is kind of what it was advertised as. But some people get the spray version and do their entire cars and crazy things like that. So check it out if you want to do some molding type projects at home. So that's all.
Yay, nice.